when we have a function of multiple variables, its output is always a single number. So it may take multiple numbers as inputs, but it has a single number for output. We can use that fact to split up some functions into a composition of functions where you take multiple values as input, but at each stage you take one number output and feed it to smaller, more distinct one-dimensional functions that take one input and have one output. Anyway, the idea here is that if I have two functions, a one-dimensional function f and a two-dimensional function g, if g is continuous at some point, and then I take the output of that function at that point, and if f is continuous at that output, so don't think of this really as a function anymore, think of this as just a single number output. If f is continuous at that number, then this composite function, where I say f of g of xy, is also continuous. So an example of that would be something like this, e to the sine of x plus y. So sine of x plus y, we can think of that as a 2D function because it's taking two inputs into the function. But we can think of this f function as e to the something, e to the x. It only needs to care about what the output of this sine is. So when we look at this, sine of anything, sine's always continuous for every value on its input. It doesn't matter what x or y is, it's always continuous. Similarly, e to the x is continuous everywhere. So we know by definition, since this is continuous everywhere and this is continuous everywhere, that this is continuous everywhere. And this is kind of a simplistic example, but you can have incredibly complex functions, and the key would be to break them into pieces and kind of work your way back to find if there were any hiccups in continuity. And you could trace your way back and say, okay, well, I know when I plug in this value, I'm going to get some sort of discontinuity. And that can help guide you in breaking this into manageable pieces.